Hello sir, I myself Gandikoda John Babu. Now I am going to explain about the home automation and the concept which are explained in home automation internship and also the new things I have learned during the internship and the simulation of the project I have done. Topics learned during internship. They are C programming, microcontroller, embedded systems, IoT and using Blink app. Now, coming to the first week, we have learned about the C language, and in C language, the introduction is about C is used in system software development, embedded software development, and also it's used in operating system for kernel development. C has several types of data type modifiers and qualifiers, and data types are nothing but the integrals and floating points. In integral, it is two types, that is characters or integers. Floating point comes under two. They are float numbers and double numbers. And coming to the modifiers, it is of two types: size, signess. And coming to the size, there are three types. It is short, long, and long double. Now coming to the signedness, these are also two types: signed and unsigned. Now coming to the qualifiers, these are also two types: conditionals and volatile. Now conditionals and loops. Coming to conditionals and loops, conditionals are nothing but single iteration and multi-iteration. Single iteration means it contains the condition based iteration, which is if, switch, case, etc. And multi iteration comes under for, while, and do while. For, while, do while are used widely for many projects. And also coming to the operators, C has several types of operators. They are assignment operator, arithmetic operator, logical operator, relational operator, and bitwise operator. And the symbols that instructs the compiler to perform specific arithmetic or logical operations on operands are nothing but the operators. Next, coming to the arrays and pointers, an array is nothing but a collection of data of same data type. Pointers to achieve the similar results as a result of pass by value or pass by reference. And parameter passing mechanism in function by passing the reference, which is nothing but pass by reference. Now coming to the function, a function is a group of various statements that perform a task together. Storage classes. Storage classes are used to describe the features of a variable or function. The storage classes are of four types. They are auto, extend, static, and register. The C processor is not a part of the compiler, but it is a separate step in the compilation process. Example: hashtag define, hashtag include, that like. Now in the next week we have learnt about microcontrollers and its architecture and the blocks involved in microcontrollers. Coming to the microcontrollers, we have first learnt about ADC block and DAC block and timers and counters, PWM, processor, memory and input output ports, microprocessor, microcontroller. Coming to the ADC, ADC stands for analog to digital converter. It is an electronic device used for converting an analog signal into a digital signal, and vice versa. DAC means digital to analog converter, which is nothing but which converts the analog data into digital data. Next, coming to the timers and counters, a timer uses the frequency of the internal clock and generates, and a counter uses an external signal to count delay pulses. PWM. PWM, it is a technique wherein the width of the digital pulses is adjusted to generate different average DC voltages. Now in Arduino we know that it runs under 80 mega 32 microcontroller, and Whereas we coming to the differences between the microprocessor and microcontroller, a component that performs the instructions and tasks involved in computer processing is called a microprocessor. And coming to the microcontroller, a compact integrated circuit designed for a specific operation in an embedded system that is called microcontroller. Uh, Coming to the memory and input output ports, timers are connected to CPU externally in microprocessors. CPU and all other elements are connected integrally in microcontrollers. And the microcontroller used in Arduino is 80 mega 32, and it's a low power CMOS 8-bit microcontroller based on the AVIA. It's a RISC architecture. It optimizes power consumption and also high processing speed it approaches. High flexible and cost effectivities. Now we going to the next session. We have seen about the embedded systems. Also we have to discuss about the architecture. Embedded systems it's nothing but the combination of hardware and software that perform specific tasks. That means embedded is the combination of both hardware and software. That means it involves both coding and also the hardware components. Now, the specific task. Embedded systems are widely used nowadays. We are using everything that includes embedded systems. It performs specific tasks. The types they are standalone and real-time, network and mobile. And the components are sensors and the physical components are sensors and smart actuator and analog to digital converter and digital to analog converter, etc. And the embedded control system has user interface and common interface. Now the requirements of embedded system. The requirements that's why embedded systems are designed are the embedded systems are highly reliable and cost effective and it consumes less power. That's why we prefer embedded systems and it has performed fast processing. And Internet of Things. Internet of Things is nothing but the devices which are connected by internet and we can control through internet. When we see the diagram given here, the IoT device is connected to a router and now through IoT device we are giving instruction and that instruction passes through the IP and that passes through network and to the cloud and the application will be performed finally. Now this is called the Internet of Things. That means using internet we command the device. We can control the device using our mobile phone and remote, etc. It technical requirements and challenges, first principles, etc. And the Internet of Things describes the physical objects with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the internet or other communications networks. An inflection point, in a general sense, it is a decisive movement in the course of same entity, event, or situation that marks the start of the significant. Now, coming to the challenges is IoT regulation, development, security, privacy, and standards. Now, there are 7 principles in IoT, and we move to the next session Blink app configuration. We know now in our internship program we have used the Blink app configuration. Blink app is nothing but the app here we are used to control our virtual device we have created in Pixim Lab through our mobile phone. How to create new temp and blink app configuration. We have learned about the how to use the app. First of all, we have to create our id. So to create our id, we have to first create a template which includes our device name. After creating template, we have given a template id, and using the template id we can connect the pixim lab, arduino and our mobile phone. Now, first of all, in Blink, we have to create new template, and next we have to add device, and after that we have to select the data stream. Data, the data streams are nothing but the here switch temperature, virtual pins, etc. And the data pins are nothing but the see here the data pins are switch temperature, virtual pins. These are nothing but switch is access switch, and the temperature is nothing but we describes the temperature. We can give them any values or any names, and irrespective of this color, we can give the switch values, and finally we have to save the data stream. Now, how to blink include the blink library. There is a code in the Arduino IDE. I will show you later, which includes the Blink library. Blink library we have to install in Arduino coding. Now the hardware components are here virtually done, and they are hardware components are virtually simulated in Pixim Lab. And first of all, the board we are used here is the Arduino Uno board. Arduino Uno board contains a reset pin and 15 digital pins, and it contains analog pins of 6 analog pins. uh, Analog pins are widely used for input, like taking inputs like sensors. Here we have used the sensor like temperature sensor, ldr sensor, etc. The input which gives data to the board are declared through analog pins. And in Pixim Lab, we have Arduino. In Pixim Lab, we have to open the Arduino board, select the Arduino board, and we have to select the LDR sensor. We have to select LEDs in spare parts modules, and LCD and temperature system, and Ethernet, and finally serial tag. Coming to the software, the Arduino IDE, which is used here in our internship program, which is the the software which is used to code this home automation. The Blink app is nothing but the app which commands the device. Here we use Blink app which connects phone and our device. Internet is nothing but a channel which shares the data from phone to device and device to the mobile phone. And the language we are using in Arduino IDE is basic embedded C. Going to the next topic, the aim of internship is to control the cooler and heater remotely. Remotely means I have said that is nothing but using our mobile phone or remote, anything like that. To control the LED during day and night like garden lights, and to control the water tank through internet, and to create the home automation system. To control the cooler and heater remotely, we have to give some value to the heater. If the heater extends that value, then immediately the heater will off, or we can off the heater manually by our mobile phone, and we can on the cooler. To control the LED during day and night, we use LDR sensor and LEDs. Here to explain about this, control of LED during day and night. As we increase the LDR sensor, the LED light glows low, and when we decrease the LDR light, the LED will glow. To control the water tank through internet, we can control the water tank inlet to outlet through our mobile phone. To create the home automation, we have used four hardware devices in Pixim Lab in our internship program. Now, the project phases are, first of all, we have learned C programming, and then we have learned about the microcontrollers and the inputs outputs involved in it, and third about the embedded systems, what is embedded system and what is the role of it, and why you are using embedded systems, and blink app. Blink app is the connector between the device and the mobile phone or remote, etc. And now coming to the block diagram, this is the block diagram which explains whole thing about our internship we have done. Temperature control block, Blink IoT app, Arduino Uno, and CLCD temperature system. See here, the Arduino, first of all, the CLCD prints the temperature values and it also prints the notifications. The temperature system gives its temperature value to the Arduino Uno, and Arduino Uno gives commands to the heater and the cooler when we are given it through the Blink app. And coming to the Arduino Uno, it gives the temperature reading to the Blink IoT app, and it receives the heater control from Blink IoT app, and it receives the cooler control from Blink IoT app, and it receives Blink IoT app will receive the notifications about it. Water tank inlet and outlet flow control. We check the volume of the water and inlet valve control, outlet valve control notifications through this Arduino CLCD and water tank. In Arduino Uno, volume of the water, and this process will be explained in simulation part. In Arduino Uno, the Blink app will receive the volume of the water, and we can control the inlet flow and outlet valve flow of water through Blink app, and the inlet flow outlet flow will be controlled through Blink app to Arduino, and the Arduino prints the value in the CLCD, and it sends the data and receives the data from the water tank. Going to the next session is Pixim Lab. Pixim Lab is a software which is the virtual simulation of hardware components design. Now we are in Pixim Lab, which is the board we are used in this project. We have used Pixim Lab in this project. It contains Arduino Uno board of microcontroller AT-MEGA32P. In Pixim Lab, we observe different sections. They are modules, tools, help, file, board. In Pixim Lab, first we have the process involved in it. We have to first write the code in Arduino Uno, and we have to select the port in the Arduino Uno virtual port, and go to the files, and we have to load the file in Pixim Lab. When we have load the file, and after that we have to go to the modules, and we have to take out the necessary required components like input components and output components, and we have to give the pin values to them according to the code we have written, and we have to load the code. Then the output will be appear. See here is the one of the screenshot, the output appearing here about the temperature and volume. After clicking the modules, we get two sections mainly we use. Spare parts. We are showing here spare parts. They are LED, temperature system, LDR sensor, and Ethernet. The LED sensor, the LDR sensor, and the LEDR connected here, and the temperature system involves heater, cooler, and the Ethernet, which is the device which connects the which connects the blink app to the device. Ethernet is used as a channel which transfers the data from phone to the device and device to the phone. These are the parts we have used in our internship. And going to the next section, in Pixim Lab, we observe the tools section. On the tools, we select the serial tank remote for a project. We select the serial port as COM5. We have to connect a port to the serial tank. And going to the next session, when we connect the blink app, it will appear here. We are implement the project by selecting blink app. In the blink app, we are created the data streams as V0, V1, V2, V3, V4, V5. These are virtual pins which are created in blink app using developer mode. In the blink app, we already set the home automation path, and in that path we choose the cooler controller and making as the on and off. And after we executing the program present in the Arduino, we observe the water in the serial tank can be reached to maximum level. Outlet is on position and VOT is stop. When the temperature attains its maximum, then using cooler, we decrease the temperature. When the LDR sensor reaches the maximum, then the LED becomes blinks automatically. And this is the process we have shown here. Conclusion is nothing but the home automation should be simulated on the PiximLab simulator. Blink IoT mobile applications used to control the devices should be able to control the lights, temperature of the home, inflow and outflow of water in the water tank. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater, cooler and inlet value, outlet value. Using Blink IoT application and PiximLab simulator, simulated home automation where LED temperature system, serial tank resembles light. Heater, cooler, water tank in real time, gas widgets to display the temperature and volume of the water. Now we have to move to the simulation part. Now coming to the coding section. See, this is the code we have written for our internship project, home automation. Now coming to the code, this is the Blink template ID, Blink device name which was given when we are creating the Blink app and we are logging out our account, Blink account. Now SPI is nothing but the internet connection, and the Ethernet is defines Ethernet module. In this code we have to install the Blink library and also the liquid crystal I2C library. Now here the auth token and blink timer and liquid crystal. Blink write is a statement, and this is the code we have written. Now if we observe here, we are calling some functions which are written from the added files which are at these ldr.cpp, ldr.h, main.h and serial tank.cpp and serial tank.h and temperature system.h, temperature system.cpp and main.h. It defines the values and the virtual pins given to the each virtual device, each hardware device. Now this is the whole code, and we have calling the functions here in our code, and after this now we have to check the code if there is any error or anything we have did. So as the code is fetched successfully and there is no errors, it's done compiling. Now coming to the simulation part, this is the Pixim lab and this is the simulator, Pixim lab simulator, which contains Arduino board, which contains microcontroller AT-MEMRTE and the spare parts. In the module the spare parts are this cooling fan and this all we have explained before. Now it shows the temperature and now see this temperature, it is showing 27.37 and these are the LEDs and this is the setup of our internship hardware. And now this is the Ethernet module and this is the LDR sensor and this serial tank is available in tools. Now we have to connect some port to serial tank. Now adjust the screen to be comfortable and now once again and we have to reset the board and checking the port and reset the board. And now we have been ready for the simulation. Now connect to a power mirror monitor which displays our phone mobile screen using blink app. Note, make sure that the Wi-Fi connector. Now load the code to the Arduino board and setting the mobile phone. Now connect that serial tank. Now reset the code once and now we have observed the volume is showing here and the inflow is on, inlet value is on, the inflow is on, it's printing the value and the value keep going increasing and the water in the serial tank also going increasing and it's go on increasing the water tank. Now after the increasing of the water tank, the outlet will open automatically or the outlet will open automatically. Now we have observed the water is flowing outside of the tank. This is the outlet and the outlet is and the gauge value is decreasing. Now coming to the heater and the heater is on and the temperature is showing is 34.70. Heater off, the temperature is showing it here. In the heater on, the value goes on showing. If you on the pull controller and we decrease the LDR sensor value, now we are observing that by increasing the LDR sensor the light is glowing with respect to it. Now coming to the blink and now the volume is changing with respect to the serial tank and it is printing on the screen